And I should apologize, it's not only me, but it's also three other characters as well. Omer from Eviation, Steve from SureFly, and then Olaf from Siemens as well. So the plan is to have a short initial talk in which I'll just briefly lay out the electric aircraft landscape as we see it at the moment. And then each of Omer, Steve, and Olaf will talk a little bit about their company's activities. And then we'll move into the panel discussion. So to begin with, we see around 150 new electrically propelled aircraft in development at the moment. These are all electrically propelled aircraft programs, so it excludes rigs developed by engine companies for testing propulsion concepts. It excludes unmanned aerial vehicles, and it also excludes vehicles which don't appear to have any commercial aim. So we exclude people who are building aircraft in their spare bedrooms and things like that. So these are all 150 electrically propelled development programs with a commercial use. The pace of introduction of new programs seems to have accelerated. In the last 2 years, there have been about 100 new programs launched, and given that it took 7 or 8 years for the previous 50 to be launched, the rate of increase of development programs seems to have accelerated quite markedly in the last 2 to 3 years. If we split these 150 programs up, on the horizontal axis here, we split them by size, starting off on the left-hand side with the small stuff, down in urban air taxis or eVTOL aircraft, then general aviation, then regional, and then large commercial. And then on the vertical axis, we've split them into all-electric propulsion and hybrid electric propulsion. And you can see immediately from this that about 85% or so of the aircraft are right down at the bottom end in terms of the small end. And they're also predominantly electrically propelled, which was quite interesting to see the Rolls-Royce presentation just now when they focused so much on hybrid. And I think we'll have a little bit more discussion about that in a moment. You then see, as you move further up in terms of size into regional and certainly into large commercial, only hybrid electric propulsion is feasible for those types of aircraft at today's battery energy densities. And I think one of the great uncertainties in this arena is how quickly battery energy density can increase, and therefore how quickly all-electric aircraft can begin to reach up in terms of the size range. When we then split up the 150 programs into the location in which they're based, you can see that the majority of them are in the traditional aerospace centres of Europe and North America, and very few in places like China, which is a very big difference to what we see in the automotive industry, where the Chinese government, with the NEV policy, the new electric vehicle policy, has been very active in sponsoring the development of a new electric vehicle industry. But so far, we see no signs of China doing that in the aviation industry. In terms of representation we have today, I'm pleased to say we have representatives from North America, from Europe, and from Israel as well, so from all of the big three centres. And with that, I was going to hand over to Omer to talk a little bit about his activities.
Do I do my own? All right, perfect. Actually, it's a one, if I remember correctly. Yeah, here it is. Perfect. So it's going to be real short. Eviation Aircraft is a company that started back in 2015. We were not told we were supposed to build a hybrid, so we did an all-electric. It's a 9-seater, 2-crew Alice. That's how we called it. The aircraft is built as a regional transportation vehicle, meaning this is supposed to take you anywhere from around 50 miles to 650 miles away. As you can see, we were trying to be European this time around, so we do 1,000 kilometers on a charge. That means a battery pack of roughly 950 kilowatt hour. Going back to the charging challenges, we can definitely talk about that later. We fly 240 knots, that's 450 kilometers per hour. And the basic idea is that this is supposed to augment that piece between the way you travel your city mile, be it Steve's great vertical takeoff and landing machine or many others that were envisioned here before, and the way you kind of travel the long distance. If you want to travel to Australia, please go in a big facility, take your shoes off, stand in line, get on a big plane and fly. If you want to go in the city, you have plenty of options. Maybe soon one of them is a VTOL. But if you want to go anywhere between that distance and that distance, the regional system is broken, and we think this could fix it, mostly because of price and efficiency. That's what we do. Thanks.
Good. I just did one slide as well. We are SureFly. We are an eVTOL. I guess we're one of the 150, which is somewhat discouraging. But, you know, as I think about it, this vehicle was designed for one thing, to get through FAA certification. Our goal was to be the first through. As a result, it's a very simple vehicle, something we think they can pass. It's a hybrid vehicle, but it suffers, you know, there's compromises like it's not the most efficient, it doesn't transition, but it's something we think we can pass. But there's a pilot in there, and we are testing with the FAA's permission, and we've done about 150 test flights. So it's technically it is moving along nicely, but we are hybrid just because we come from the automotive background. We make electric trucks in the United States, UPS trucks, DHL trucks, big trucks like that, and you know, just all the learnings about lithium, its current state of the art, and we since we are trying to get to market with something as soon as possible, being a small company, we really couldn't wait for the magic battery to happen. No doubt it's going to happen, but we just went with fossil fuel. We use the battery as an emergency landing mechanism. So if your generator should ever fail, you have enough battery to get down. And of course, the battery is also in all the micro balancing. It serves as a sump, if you will. But I just, the other thing is that I would say after listening this morning, if there's 150 companies doing this, I think it's fair to say it's 150 different designs. That's right, some radically different. If you're the governing bodies, if you're the FAA or EASA, and you're trying to figure out you know, how to certify these, they're just resource constrained. They're not used to this type of thing. So we wanted to get in early, get our place, and work with them. But all these regulatory bodies are just going to be under siege, trying to figure out a way. They've just never seen this diversity and this rapid innovation. It's kind of like when drones happen, but it's really on steroids because, of course, the bar is much higher with people in it. Thank you.
Okay, so that leaves me slightly more full picture here. I'm just trying to give you a glimpse into some of the things that we're doing. We're not actually developing the aircraft ourselves. We're in the inner workings, so we're making the hybrid electric propulsion systems. That's what you know, keeps us going every day, to try and make something that is more power dense and adapted to aviation's needs. And the things that we're doing cover everything from the low end in terms of size of the market right the way up into the commercial end of flight, all at various different stages in terms of the maturity. If you look at the top left, the engine there, this is something that we're doing together with a number of different partners. Aerospace, I think, is one of the most visible ones today. This engine is actually one that is due to go into certification this month. So hopefully this will be one of the first, if not the first, certified electrical propulsion systems for aircraft. All the way through the VTOL, you see a picture there of the City Airbus that had today its first rollout into the public domain. That's powered by our SP200D motors. Eviation Alice, can't really add anything to what Omer has said. He's explained it very well. I think there is a huge space for all electric vehicles. There is something to be said for the hybrid electrical side. That's what you see on the top right. So there's various project proposals that we're working on, and we're looking at building generators and motors that are more than on the 600 kilowatt and 500 kilowatt size. Regional aircraft that you see below, we're actually in the process of building these as well. So 2 megawatt motor that's due to be tested this summer, a 4 megawatt turbine-based generator that's also due to be tested at the end of the year, and then due to go into system integration. So the field is really moving ahead, and the last picture on the bottom right, this is kind of the far reaches of the spectrum. This is where we are looking at superconducting generators. That's basically the inner workings of a 10 megawatt machine. We're taking this to a preliminary design review at the end of this month. We'll have to see where we take it afterwards, because this is really something that kind of throws the ball very, very far out there. So that's a glimpse of what we're doing.
Okay, thank you very much. I was going to start off just by asking a little bit about the technical barriers that each of the panelists see to electrical aviation. I mean, people always start off talking about batteries and the 500 watt-hours per kilo, the sort of mythical figure that battery technology has to reach before electrical propulsion can become viable, or all electric propulsion can become viable. So I was going to ask Omer to start with. I mean, battery technology is obviously one limitation. What other limitations do you see as well?
I think, first of all, we need to visit that specific question with a twist. I think the real question is not, and I did see it, again, listening today, I did see it kind of intertwined in many of the talks. In many cases, the question is not what's your battery energy density, but what's your mission? How far you want to fly? If you could have flown Steve's machine for an hour on battery power, he would probably fly it on battery power, because that means he has his IFR reserve. That means the batteries are good enough to do a proper mission of a few minutes hopping over traffic in a city, and you're good. But if you don't, then it's a different question. And I think for us, that first milestone was part of the, or that first question was part of sizing the aircraft. You basically say, okay, I cannot fly at 40,000 feet, Mach 0.9, and try to build the all-electric 787 just yet because of energy density. That's true, but I'm not trying to. So the question is really, are you trying to build a tech demonstrator that will be an amazing thing to show, or are you trying to build a product that can be manufactured and certified and then sold and make money? And I think if that's your question, then the hurdles are very different. Energy density for us, for the numbers we were talking about, are fine. We are actually talking to clients saying we can fly 600 miles or 540 nautical. They say, why, that's too far, we don't need that. We fly 20, we fly 70, we fly to the next island. I think the other questions have to do with the certification process of that battery. I think it's much more interesting than the energy density of it. I think the next hurdles are probably in the area of cheap, not fly-by-wire systems as a whole, but cheap fly-by-wire solutions that could really fit into that kind of family of products that makes sense. And I think what makes it all possible is probably the use of ultra-lightweight materials. And then again, the price question comes to mind. I'm not going to touch propulsion because we have Olaf here. But again, pricing of the ability to coherently manufacture airframes over a period of time in a way that's also certifiable and safe is something that you're used to seeing by now on the 787s and the A350s. It's not exactly a program that a startup starts. So the question is, can we tackle those? And it's not necessarily the battery energy density and the propulsion of the motor. That's my take.
Same question? Yeah. Well, for our craft, since you know, there's just never been a certified craft like that anywhere in any country. So everything comes under scrutiny. The airframe, the props, the motors, the battery, the hybrid system. But I'd say the number one thing is the fly-by-wire, because it's so unique, and it's receiving the most scrutiny from the FAA, as it should. but it's, you know, sometimes the FAA, like in drone world, when they did the drones, when they started granting exceptions, they compared it to what the existing mode of inspecting power lines was. How many people die a year in helicopters inspecting power lines? And this drone, although not perfect, how many people would it hurt or kill, right? And if you were better and much better than the current, the regulatory bodies are inclined to go that way. So in our case, we're up against a helicopter, and we try to have, you know, no single point of failure. We try to have redundancy, even having a parachute in the middle of it. So, you know, the FAA has been, at least aggressive. You know, I think they really want to not stifle innovation. We're trying to use things they understand for the most part, but the software is totally from scratch, and so I'd say that's our toughest challenge.
So I think from a point of view of the electrification side, Omer's already actually covered a large span. I think there's one thing that I'd like to add on that one, and that is a question of time frame as well. So if we look at the way that building out new vehicles works and the time that it takes to bring these vehicles to market, you're looking at a number of battery generations, cell generations, and new technologies that are going to come out. So I really don't think that battery gravimetric energy density is really going to be the single biggest key issue. Certification certainly is one aspect that we've seen and that we've talked about with our partners as well. We're building out our own batteries too, and the question in terms of how to make them safe, how to give the people that are on board that safety that they need, that I think that's the most important point that we need to reach from that angle.
Okay, thank you very much. It was an interesting take on the battery question. Both Omer and Steve started to talk a little bit about the regulatory barriers, particularly around certification. One of the other barriers that we heard about just after lunch was about the infrastructure needs and the needs either for power to power these aircraft or for just the physical infrastructure for them to land. Do either of you see those as being a problem at the moment?
Yeah, we're not necessarily building an air taxi to go from point A to B and back. We're building more something agriculture might use or a paramedic to get the ambulance fast. So we're going from A to we don't know where. So charging stations just aren't out in the wild. You know what I mean? So that's another reason we picked hybrid, is because you just refuel it and you're ready for another hop. And fossil fuels just, at this point in life, just much more convenient. But it's, like Omer was saying, it's 4-year duty cycle. And if there is a safe, the premise, I think, of all of us, all 150 of us, that's really bugging me now that I know that figure. You know, there's about, in America at least, there's about 750 civilian helicopters sold per year of all manufacturers combined, right? We've already got 250 pre-orders for our vehicle that's still a couple years out. And that tells you we're not cutting into necessarily the helicopter market. If there's a safe thing that's easy to fly and easy to land, you're just going to find a whole crop of new uses for it that we never dreamed of. Just like if you're flying from Cincinnati to Chicago, which is, a 1-hour flight, things you never would have dreamed you're going to do electrically now. So it's what's it like? It's like electric cars used to be. Tesla used, well, not Tesla, but kind of the world thought electric cars are going to be sold based on their economy. Really, but really they're selling because they're so fun to drive, and they're just great. And you're going to see that happen here, I think, as well. There's just uses nobody's dreamed of yet.
If I can, Steve, first of all, I couldn't agree more about the reason of selling or the reason of buying an aircraft like this. I think it should work in terms of the economy, but in many cases, what you'll see in the beginning is This is the plane, or this is the helicopter replacement, eVTOL, doesn't matter what you call it, that is built like a plane should be built in the 21st century. Yeah. What we're looking at all around, those 750 helicopters, those, I don't know, 600 and a bit, probably 700 general aviation aircraft of our size, are basically designs that were made back in the 50s, at best 60s or 70s, and that's what you operate. You would never dare operate a car like this unless you're in Cuba. And that's something that we take for granted. Now, I think the infrastructure question is really interesting because we're building two very, very different machines, but we took the exact same approach. You don't know yet where your market is going to be. You know where you think it should be, and you're saying, I want something simple that could run to market, so let's do fuel. We said, you know what? We want something cheap that people will want to climb on as passengers, so we do airports. We have to do airports. We're not trying to reinvent infrastructure. We're trying to take a regional operator and give him an answer to his existing setup. Today you pay X for your flight hour, probably $600 or $1,200 per flight hour. Let's do $200 and change nothing. Now, the way to do it is to solve exactly for that. How do you charge? Well, you build this big Bowser, mobile battery with a charger, and you charge it off the grid when you can, and you charge the plane as fast as you can when it's on the ground. And that's your mobile solution. That's that. Now, will it grow with economy? Absolutely, everything grows with economy. So I think the infrastructure question here is a question that we'll start seeing when we really push the boundaries of operation. If you really are going to see 100,000 flights into LA every morning like Uber envisions, that's an infrastructure problem. If you're going to sell 600 of those as early as possible, you won. No infrastructure issues there.
And Olaf, do you have any views on infrastructure? I was thinking Siemens is a big diversified business that does a lot of power generation as well.
It's true, power generation, transmission, distribution. We have charging stations ourselves, so we're looking forward to the electrical future in terms of airports as well. It's definitely something that needs to be taken care of and done, and I saw a question down there in terms of how long will it take to charge planes, and that obviously is dependent both on the power that you have available at a certain point, but also in terms of how much energy you can actually provide over a certain time span. So there is a lot of infrastructure built out that does need to be done going forward. But I think it's going to be a step-by-step approach. If you look at the planes that are smaller, most of these are at smaller airports. You're not looking at huge turnaround times there. They'll be sitting around for a day or two or three even sometimes. If you're looking at commercial transport, there you need to look at turnaround times, and there it does become crucial. You can recharge the batteries if you're looking at a battery-only powered vehicle, just as you can recharge any other batteries in an electric car. So the question mainly is, how do you get the heat out? If you're looking at really fast times, if you want to push the 15 minutes or even less, then you need to look at actively cooling the batteries somehow. So there's a lot of technological challenges involved in there. Everything I think sort of that sits around the kind of hour mark to 2 hour mark in terms of the time that you have, that I don't think is such a big deal in terms of getting it done technologically. And if you move into the hybrid systems, and Steve's system is a hybrid system, albeit one that only uses the battery as a safety backup, then you might not have to worry about recharging the battery when you're on ground at all, because maybe that's actually integrated in terms of your mission profile. Maybe you're just using the battery as a booster. So I think there's a lot that you can again play around with. But I think of all the airports that I've talked to so far, they already have that on their radar screen, because if you look at infrastructure build-out, that's something that's being done with a 10-year time frame normally plus. And so a lot of people have actually phoned into Siemens to ask, well, how much should we provide in terms of energy to the airport? So it's definitely on people's mind.
If I can add a note on that. First of all, I think the question of combining kind of the operation to the turnaround is really the important one. For us, it was the actual sizing. I mean, I'm sure that, again, for Steve, that was, okay, the battery is only going to be a buffer for safety because that's what could pass FAA. for us, and I see the questions here kind of coming back and forth, our plane is built so that for an hour in the air, you need roughly 20 minutes on the ground, anywhere between 20 and 30 minutes on the ground, depending on how quickly you started your fast charge. Now, that means that we are charging at 500 kilowatt. That sounds like a lot because it's nothing like a car. But guess what? It's nothing like a car. It's a plane. We have a huge battery, roughly 10 times bigger than the biggest Tesla. That means that when we charge it, even at 500 kilowatt, we're only charging it at half of its rated capacity, meaning we don't heat up so much. So it's really a question of how did you size your vehicle? How did you solve the general problem? And we didn't decide on the 1 hour in the air for a half hour on the ground rule for ourselves. We asked the client. And once the client says this is what he wants, well, why not? Oh, that's a good question. First of all, well, this is the community, so you guys are invited. We're gonna show the Alice at full scale and airworthy aircraft at the Paris Air Show in 3 months. We have our CTO in the back, Lior, 3 months. God help us, right? Yeah, so we're integrating as we speak, and paint and integration goes hand in hand, and it's going to be ready for that, which is quite exciting. Cert and deliveries, we expect and plan for just over, well, up to 3 years, let's say. So we're talking about test flights this year, but the real question is always, when can I buy a ticket, right? So yeah, we're talking probably operations in 2022, not before that.
And the commercial question brings me back to the whole question around the business case for these aircraft. Can you ever make money out of manufacturing or developing and manufacturing these aircraft? Obviously, Omer probably believes yes, I would guess. Steve, do you have a view?
Yeah, I mean, we're, again, coming from cars, I think everybody realizes automotive is a volume game, right? And aircraft typically isn't volume. To make our price points, we've had to promise our vendors a certain amount of volumes, and just like automotive, that magically comes down. So the price, I saw a question on the price of our craft is $200,000. And we are in type certification. We're about 8 months in, and I think it's going to be at least another 2 years, but it's going well.
We're a bit more expensive, I'm sorry. We're at anywhere between $3.2 and $4 million, which is more or less the equivalent of a turboprop of that size and performance today. Actually on the lower edge of that, but performing slightly better. I think back to your kind of more general question, is there money to be made in this industry? Well, I hope for my investors that yeah, but the real question I think is not, well, it's not a general question. There are plenty of use cases that could be pointed out, but the real question is, are we looking at a shift in the way we view, let's say, small general aviation as part of the fabric of transportation? That's the huge pie that aviation today is really not touching. If you look at what Steve's doing for 200K, can you buy a helicopter that will operate over anything? No.
You can't do the same job with Steve's machine that you do in a helicopter, never.
Exactly.
Most of the transport.
But the cost per flight hour is going to be so dramatically different that in some cases, and you know what, I want to take us, excuse me for a second, but think about it this way. In the early 20th century, if you were super rich, you had a driver, you had white gloves, and you didn't have a horse. You had that automobile thingy. Well, if today you're super rich, you have a Gulfstream, and your driver wears black gloves, and he's a pilot. Or you have a helicopter. Why? Because it's terribly expensive. If you ask me, and I love aviation, I love helicopters, it's not an aircraft, it's aircraft parts flying in formation. It's a very, very complex machine. Sorry. And the simplicity of what Steve is building, the simplicity of the systems that we're implementing with Siemens, the simplicity of the electric propulsion system really gives us the promise of extremely cheap direct operating cost. That's the heart of it. And it's fun to use, and you can control the propulsion system 400 times a second, and you can control surfaces faster because you have to be fly-by-wire anyway. So this is the way planes should be. Now, is this the next revolution? Is this, did we have the powered flight and then the jet age and now the electric age? I think so. I think these are the good old days. But time will tell.
And is that the reason for Siemens' interest in the market, given your pedigree as an electrical systems company?
For us, it's just a labor of love. We're not in this for the money.
Actually, that's great to hear.
No, I mean obviously, like a company like ours, obviously we do our business research, we do our business case analyses and everything. So we do have an idea in terms of where it's going. We do know what things cost, what they could cost, and where they could go. We do believe that this is actually the single biggest revolution that's hit the aviation industry since the dawn of the jet age, maybe. I mean, we're looking. You have to look at it, I think, from two sides. One is the point of the or a cause and an effect. One is the operating cost, and just taking the things that are very near term, right? So take the two-seaters that are out there, and take George By, who's also running through FAA certification at the moment. And I think in terms of complete operating cost, if I remember it right, he had something like $20 per hour. Now, if I fly with a 152 or 172, I pay 130, 140 euros per flight hour. And it's just there's no comparison. We're looking at a factor of 5 or 6 lower cost. And that's going to translate to bigger platforms as well. And that's going to transform the operating costs in this industry. And what that means is you're going to see a huge demand in terms of volume. You're going to really be able to revitalize the regional aircraft market, and not only because of the operating cost, but also because of the other promises that are in there from the point of view of electrical aviation. You have the ability to be much more silent, and there's some great videos that you can watch on YouTube already of people trying this out. There's project concepts. We're working together with one where people are aiming to build planes that you're not going to hear from a distance of 50 meters anymore. And this is just going to completely change the way that airports work. We're being called in today. We've got some demonstration platforms that we're running, and we're being called in from local airports in Germany who are saying, they're all saying the same thing: we are being shut down. People don't want to have an airport next door because it's just too noisy. They're fed up with it. And they say, can you guys come and fly your demonstration airplanes so that people hear that the future is going to be different, and that they see that this is going to be a fantastic economical factor actually for them to have this airport around. And what that is going to drive in terms of volume, and this is something that we believe from the Siemens side, which touches another part of our business, which is the whole question of digitalization and automation. We think that we're going to see a change in the way that aircraft are made. Today, you have a lot of manual labor of love to build these things, and if somebody goes and gets a production run of 20 aircraft, there's a celebration, champagne corks start flying, everybody gets bonuses. Well, the point of the future is not that. The point of the future is that you're going to see 1,000 or maybe 10,000 of these aircraft being built, and all of a sudden you're going to talk about manufacturing scale. You're going to see a rapid price decrease that's going to happen. That's again going to reinvigorate the market. So I think where we are from a point of view of what's going to happen in the industry is tremendous.
Okay, I think we've only got a minute or so left. So I was just going to ask my three panelists the question I always ask on these sorts of events, which is, when do you think that you'll see a 50-seater aircraft making a fare-paying journey between London and Paris with a hybrid electric aircraft to start with?
You first. Okay. Including Brexit 2035, and if the UK comes to its senses and decides to stay, then it's going to be 2034.
I'm doing a two-seater, so I'm not really a good guy to ask.
I think Olaf was more or less spot on. I think you can have, by the way, at this distance, you can fly all electric by 2035.
That was going to be my next question. All electric 2035 as well?
I believe at these distances, yes. Across the Atlantic, different story, but this, no problem.
The question is how many people, or will we still have the same number of people flying from London to Paris? Because, you know, if we have the smaller planes, maybe I don't want to go from London to Paris. And we had the discussion earlier on, you know, maybe I want to go from Southampton to Lyon, which I can't do today, but I could tomorrow.
Okay. Thank you very much.